Hello, I am Tejaswini LP, Department of Physics, VCT Puttur. Now I am going to explain an experiment that is a spring constant. Aim of that experiment is to determine spring constant of two springs S1 and S2 and spring constant of two springs in series combination and parallel combination. This experiment is related to elasticity. Elasticity is a property of a material to retain its original shape and size after the removal of deforming force. Here we study one law. That law is called as Hooke's law. According to Hooke's law, restoring force is directly proportional to negative of displacement. It is given here. You can see that here. Restoring force is directly proportional to negative of displacement. Force is taken as F and displacement is taken as X. Therefore, we get F is equal to minus Kx, where K is called proportionality constant, or it is called as force constant or a spring constant. So, we can rewrite this equation as K is equal to minus F by X. Now we will define K, that is spring constant or force constant. By substituting X is equal to 1, we get K is equal to F. So use this. Force constant is the magnitude of the applied force that produces unit extension in the spring. Unit extension is given here while it is loaded within the elastic limit. So this is the definition of a spring constant or force constant. Now we will find out the value of K for different springs. We will go for experimental part. Apparatus used here, one stand as well as two springs. One spring is already hanged here. This is one spring S1 of spring constant K1, another spring of S2 of spring constant K2. Now we will take the readings, how to do the experiment. This is one weight hanger, so its weight is taken as W. Hang this weight hanger here. There exists a small displacement occurs, and make sure that spring should not vibrate. It should be stationary while you take readings. Okay, now it is stationary. Now keep that scale here like this and note down this value on this scale and write that value in your table of column which is shown here. So you can see second column, that is a W. I have not taken any load there. Load is said to be 0, so only weight hanger W. And displacement what you are taking in that scale is written here. That is for example 50. Next, you add 50 gram for this slotted weight. For this weight hanger, this is slotted weight of 50 gram. Okay, like this. Now displacement increases. Once again, you take reading. You can take a reading here like this. This reading you have to note down and write in the table of column. Right here. For example, it is a 46.8 centimeter. Similarly, you have to continue the experiment by adding 50 gram each time. So next value is a W plus a 0.1 or W plus a 100 gram. So you have to continue the experiment up to W plus 0.20. So these are the displacement readings you have to write. So next to that calculation part, I will explain calculation part first. Here F is equal to mg. So m is mass, g is acceleration due to gravity. Mass is 0 here, that's why force is 0. For second column, here mass is 0.05, g is acceleration due to gravity 9.8, multiply you get 0.49. Do same procedure up to here. Then elongation column. Elongation you have to find out by subtracting all these values from first value. So first one will be 0, then 50 minus 46.8, you get a 3.2, like that you get all values. So last column is to find out spring constant. Here it is shown K1 is equal to F by delta X, and it is given in Newton per centimeter. F is this value and delta X is this value, you get 0.153 Newton per centimeter. Similarly calculate remaining values. After getting 4 values here, you get mean of that. Mean value will show. Mean value is shown here. It is in Newton per centimeter. Write it in Newton per meter as 14.55 Newton per meter. So this is the experimental part as well as calculation part for one of the spring S1. Similarly, you have to replace this spring. Replace this by another spring like this. Do same procedure. Find out the spring constant K2 of this spring. So for individual springs experiment over. Next we'll go for combination of springs, that is a series combination. So in series combination of spring, hang one of the spring here, then hang another spring here. So end to end connection is called as a series connection. It is taken as a series combination of spring. For this combination you have to find out spring constant. Once again hang this weight hanger here. It should not vibrate. Again you take readings. Note down this reading and write in the table of column. So procedure is same as that of individual springs. Go on adding slotted weight of 50 gram each time and note down the reading. Those readings you have to write in table or column. This is for series combination. Next we'll go for parallel combination of springs. For parallel combination of spring you have to remove this. Hang that spring here. Take one more support for that. This is a lightweight. This wooden piece is lightweight. Hang that weight hanger here. After hanging that, take reading. Note down the reading from the scale. Once again add 50 gram. Now displacement increases. Note down that displacement. Okay, here you have to take readings. So that is about taking reading in a parallel combination. Next we will go for calculation part of series combination or for parallel combination. For any one combination I will show calculation part. Say for example parallel combination. Okay, mass same as that of individual spring. This force column is also same. Displacement you are writing from that scale. Elongation, subtract all these values from first value, you get elongation in centimeter it is. Then you are calculating spring constant from the graph. And last column theoretical value Kp is equal to K1 plus K2. What value you are calculating individually for spring S1 and S2, that is K1 and K2. Substitute here, add those two, you get for example 29.25 Newton per meter. Then you will go for spring constant from the graph. In a graph, one graph I will show here. Along x-axis you have to consider elongation delta x in meter. If it is written in the table of column as in centimeter, here you multiply that by 10 power minus 2, so it will be in meter. And along y-axis you have to take force, it is in Newton. Then mark the points, find out slope. Here you have to calculate slope, substitute the values. For example, you get 25.94 Newton per meter. Substitute the values, measure this, multiply that by scale, measure this, multiply by x scale, you get this much. This is for parallel combination. Similarly, for series combination, formula used is Ks is equal to, for series I have not shown, Ks is equal to K1 K2 divided by K1 plus K2. Substitute the values of K1 and K2 and you get the value for Ks, that is a theoretical value. Similarly, graphical value you have to write here. What I have shown one graph here, in the same way you have to plot graph for series combination. So we get 4 values here. One value is K1, spring constant of spring S1. Another value is K2, spring constant of spring S2. And third value is equivalent spring constant in series combination Ks. And fourth one, equivalent spring constant Kp in a parallel combination. So all those values you have to write in the result. Thank you.